Many of you who have jobs know, nobody cares how good a grade you can get on a test. It's about what you can do that really matters in the workforce. And so we want to fuel these high school students with the experience and the knowledge and the interest to take this creating, and it's no longer building these things, it's no longer work, it's something they want to do with their lives and carry forward, not just for a paycheck, but also because that's what they want to do with their time here on the planet. So I encourage you to get your students to keep on building, keep on making stuff. They've learned tons here. They know how to do it. Don't let them tell you they don't know. But we're very proud of them. I'm sure you will be too. They'll each come up and speak briefly about their project, have a question and answer session. But before we do that, I wanted to introduce our remarkable staff. So in back, the video camera is you. Go ahead.
Hello, I'm Yu Zhou. I'm a graduate student from Rice University, and this is my first time to become a staff member at Blue Stamp Engineering.
Hi, I'm Alan Gregory. I currently do a lot with robotics education around the Houston community, for HISD, for some of the private schools as well. I've been doing robotics, competition robotics since I was a freshman in high school. So I was in their place at some point, and I had mentors who worked with me, so I'm very happy to be able to do that again. And this was my second year doing Blue Stamp. I was here when we started the Houston program last summer.
I'm Rachel Alexander. This is also my second year working with Blue Stamp here in Houston. I graduated from Rice in 2012, and since then I've been teaching at Reagan High School, where I teach robotics, computer programming, and engineering. So
So I don't want to chew up too much time up front. The real stars are yet to come. With that, who wants to start us off? Come on. Where's Terry? His hands up.
My project, so you can see it. I don't know if you can see it, but it's called the electromagnetic floater. I'm Terry. I'm a rising senior at ES Prep Southwest, and my project was the electromagnetic floater. So pretty much the way it works is I have it powered by a 9-volt battery because for the electromagnet to work, the range of voltage for it is from 6 to 12 volts. So 9 is right in between that, so it's convenient to have a 9-volt battery around. And I only have 2 inputs and outputs for the Arduino to use. The Arduino, I use pinouts 8 on the Arduino, pin 8 and pin 9 on the Arduino, and hook it up to the H bridge. H bridge is something that I can use to control the electromagnet. And depending on whichever one is high or low, I can control the flow of the electrons, so I can control the polarity of the electromagnet here. So the way I have it hooked up is I have the electromagnet here, and I can upload the program that I made earlier, right? And then I can take magnetic objects or just metal objects and let them attract to the electromagnet. But I needed to get the electromagnet working to get things floating by having it turn on and off really quickly. So I'd have to turn it on and off 200 times per second. So the force of gravity would be pulling it down, the object down, while the force of the electromagnet would be holding it up. So what I did to do that is I used PWM, which is something that I can use to cause it to float at a certain range. I also had a IR sensor, photocell, which pretty much tells me the amount of light which is in my, in my area. So like if I directly, if I put a light directly on it, it'll give me a reading of, something from 700 and above. And then if I, close it, it'll give me a reading of 11. So it's very sensitive. And I would use that to tell the different distance in which the object is how close the object is compared to the top of the electromagnet. And then, yeah, I would get it floating. So I would change to get it floating at a steady pace, at a steady area. I would have to have the how I said 200 repetitions of on and off per second. I would have to increase that time, the time in which it's on when it's low, and I have to decrease the time in which it's on when it's high, when it's close to the electromagnet. So right now it's on, it's working. We got the electromagnet working, so yeah, that was pretty good. And yeah, and for my starter project, I had a security system. I had like once the read switch closed, once the read switch was so a read switch is something that allows something to complete the circuit, right? So if I have a magnet that's close to the read switch, it'll keep open like this, so the circuit won't be completed, right? So once the circuit is completed, there's an LED that'll turn on, and then there's a speaker that'll turn on as well, so that I can have somebody noticing that the wire has been tripped. So yeah, those are my things. My next step is just to have an LED on with a photocell, so that so I can tell more accurately which values I need to put into the Arduino, so that I can have the the object floating at a certain height. So right now it just attracts. I say. So it's up there. Are there any questions?
Is the frequency of your switch on and off, you said 200 times per second, is that mass dependent, depending on the object, how heavy it is?
Yeah, it might. So the time that it's on, needs to be greater when it's a bigger mass. Like when it's a bigger object, you might need a greater time that the electromagnet is actually on. So.
Yeah, how do you figure that out? Do you just trial and test, trial and error, or do you actually have a formula to figure that out?
I don't have a formula. It's just trial and error for now. But I hope I'll figure out a formula later. But so yeah, it's
Okay. What's the relevance of what you're doing, your project? Where is it relevant? In real life.
In real life, okay. In real life, it's in the field of biomedical engineering, because there are these people who made a petri dish. Like they wanted to show how they wanted to make the growth of bacteria more realistic, so they made it in 3D form. So they made it in a petri dish, right? You know how a petri dish is flat, right? But you had to. I mean, what they did is they had a petri dish that was flat in the center, and then they had it curved on the edges, right? So they would have they would put metal filings inside, so that when they put the magnetic lid on top of it, they would just float in midair and have like bacteria growing. And then also for trains, you can get rid of friction by using magnetic levitation to do that.
So where did you get the idea for your project?
In Louisiana, they gave us like a list of ideas that we can use for our main projects and starter projects. So
wants to go next? Yeah. None.
Hi, my name is Hernan. I go to the Chicken Preparatory School, and I'm a rising senior there. And for Blue Stamp, just as a starter project, I decided to work on a parking radar kit. And what it does is it's very similar to just basically any radar kit that any car has nowadays, that it helps you back up. So it helps detect objects as you're backing up, so you don't crash into something. But for my more intensive project, I decided to work on the RC tank driven by Arduino. And the RC tank in itself was a completely learning experience, as is Blue Stamp as a whole. Because at first I went in with no experience and I had no idea what I wanted to do. But I saw the word tank and I was like, oh, that seems pretty cool. And so I went in and I decided to do this. So the most important things for the tank is that there are three important parts to it. There's the Arduino Nardo, which is really the brain of the whole tank. And then there's the level shifter, which is under here. And the level shifter, what that does is that it interprets all the signals that this controller gives to it, and it communicates it now, and that leads to the third part, which is the dual motor carrier, which sends signals to the gearbox. So to summarize it all up is this sends signals, and it's interpreted through the dual motor, and then that way it'll tell you, or it should go fast, but the tank is ultra sensitive, so it tends to go really, really fast. But I had to work with a lot of different things. So I had to work with programming and soldering, which was really difficult, which is one thing you learn the first day at Blue Stamp. And I have to admit that I did burn myself a few times, trying to deal with the same wire, which was frustrating. But it was really worth it. Like now, seeing like the whole tank, it's like working with like even the code, which I knew nothing about. So you go in and you hear about a library. I had no idea what a library was, and then I found out, well, it's just a collection of code that tells a certain thing what to do. So I had to go in and start from scratch and learn everything that that certain code did. And the short of it is that I interpreted it, I took out what I didn't need, and I built my own code based off of that library. So now I have a working RC tank, and better show how it works. So this is it's working. So as you can see, it's very satisfying going through all that trouble learning what a library is, and learning really how to solder well, how to make good connections. And the end product was this. And also, I think another cool thing is that because it's Arduino controlled, it really allows for a lot of attachments that I could possibly add to it. So that could mean that I could add a temperature sensor for it to tell me sort of what temperature it is. And with that, the long-term idea that I wanted to do was, I have this, and I can take it and just basically do almost anything I want with it. And what I really wanted to do was add a carbon monoxide sensor, a temperature sensor. So the real world, I guess the real world connection to that one would be, it would be helpful for first responders in case they want to go into a building to keep them out of harm's way. They can send a little RC tank there and see if there's any dangerous gases or if there's really a fire there to keep them safe and keep things as safe as they can be. But really, I get decide to go that route, or there's other things I can add to it, like a bunch of LED lights, which is really cool. So this is the RC tank, and thank you very much.
Questions?
Yeah. Are there any questions? Sorry.
What was the hardest part?
There were two hardest parts, I think, of the whole program, which is actually figuring out how to assemble the gearbox, because the directions weren't very helpful. So I had to, for me, kick it back old school, like when I was younger, and just look at the picture and kind of go from there. And the hardest part was actually learning the code, because, as I said, the library that it had was supposed to function for Guitar Hero remote controller, and so I had to figure out exactly what I needed and what I didn't need, and incorporate also algebra, which I thought I didn't really. I thought I wasn't gonna come into it as much as I thought I was gonna do into this one. I thought it was gonna be really straightforward and be nice to me and just work. But that was the harder part, learning how to write it down in code, code everything. So that I think for me was the hardest part. Any more questions?
I guess that's a remote control car then, huh?
Yes.
All it is?
Yeah, all it is a remote control card, but there's a lot of room for improvements. So all these buttons, the only thing that works in the remote controller, the only thing I allowed it to work on the remote controller is the analog sticks. So everything else is essentially turned off right now, but at any time I can just go back and reactivate it, so I can add an LED light that turns on whenever I hit the square button. And so for right now, for now, it's a complete project that I can have fun with. It's an RC thing.
turning in circles because it's everywhere. But if I cook my hand, it'll completely stop. That's And for my intensive project, I decided to build a solar powered speaker system. Basically, the solar panel is supposed to charge the battery inside the speaker. And once I finished, I decided that I wanted to charge my phone or anything else using USB, and it can. So I bought my PSP because I can't find my phone. Right now it's charging from battery, and the power button, right, the power light is orange. I don't know if y'all can see that, but it's orange. That means it's charging. Right now I'm going to test the solar panel. I'm going to take the battery out doesn't work all the way because, as I said, it's a light bulb, and the solar, it's not getting enough voltage to the solar panel, so it's not gonna work as well. There it is. And I'm going to show you a SketchUp model, which is a 3D model that I made. And for me,
Yeah, just do it on the computer. There you go.
Alright, so this is my SketchUp model that I made. And this was the hardest part for me because I made about 4 3D models, and the first 3 had wrong dimensions, and I found out that you have to have like accurate dimensions with accurate lengths, so you know how big you need to drill holes and how long your how long the parts need to be so you can connect it. And it took me about 2 weeks because I kept messing up and starting over. So this is my final model, and you can see it looks very good. So that's my project. Any questions?
How much power can the solar panel produce?
It can produce up to 6 volts of power from the sun, but from the light bulb, it can produce up to 3.39 volts to 5.36. Anybody else?
Who's next?
Okay, so, my name's Juan. I'm a rising senior at Kissimmee High School. Okay, and for my intensive project, I decided to do a voice control robot. And so basically how it is, this is the power, which powers the entire robot. I had to make a base and 2 servos that let it go. And this is the mic. So how the robot works, it knows English, Spanish, French, and Japanese. So I could give it commands in 4 different languages. And I'm about to plug headphones into it so it could talk back to me so it knows when I'm speaking to it. I'm responding right now. So what I'm gonna do, since it isn't responding, I'm gonna upload some old code into it. So that old code only has English and Spanish. So I'm gonna demonstrate the French and Japanese right now.
what kind of commands can you give it?
Basic movements, that's the simplest I started, because I wanted to make sure it knew different languages, because they was kind of cool. This may take a while.
I have a question, sir.
Yes.
Will these commands only be heard and taken by your voice?
No, well...
Is it by anyone?
By anyone, basically.
Okay.
As long as it's the same command.
Yeah.
And it sounds a little bit like me.
What was the most difficult part?
Well, I enjoyed every single part of it. It was challenging. Oh, now she's working.
What's her name?
Her name is Lucy. Okay. Lucy. Move. 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 That's a lie. Lucy. That was 8 noise. Move. Move. Wow. Now I'm going to Spanish. Lucy. Lucy. Spanish. Adelante. The LED changed colors because I programmed it to change colors according to the type of language. So English is green, orange is Spanish. And since it's only a 2-color LED, French is green and Japanese is orange. And now we'll do French. Lucy. Lucy. French. Ali. 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 I wish I could hear her because she's singing. Ali. Ali. Baku. 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 Turning. Turning. Okay. One more for Japanese. Lucy. Lucy. Japanese. Japanese. Japanese, 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 Iku, Iku, so that's how my robot basically works. Any questions? Dave?
What is she saying back to you?
She's really rude. She's just saying S is denied and please repeat it. In a really mean tone. Any more questions?
Why'd you name her Lucy?
Oh, well, actually,
First you went from like
yeah. Well, first, it went through like a crisis. It had like 5 different names. The first name was Bob. No, the first name was Arduino, then Bob. Then I got frustrated, so I called it My Slave. And after that, I called it Heather, because then I found out it was a girl. And then I ended it with Lucy, because I like that name.
How do you know it's a girl?
Because it sounds like a girl. Any more questions? No?
Who's next?
Hello everybody, my name's Daniel. I'm a rising junior at Sharpstown High School. So starting off with my project, I started with the RC robot tank, same thing as Hernan. Me and him have really like helped each other, but he has helped me more, so really thankful. Well, the main thing that is hard about the project is having the codes. The codes, me and Hernan were just struggling in the move. We were like, what does this thing do? Like, we didn't know what the code was for, like, until Alan just told us, like, that you have to control the Arduino with an equation, like an example. So, like, the controller, when it goes forward, it goes to a power dimension of 256, and when it goes backward as well. So, the maximum speed of the gearbox is 255. So, 256 would not let it go forward or backwards because it was too much. So Alan actually helped me get a code which was activating actually on minimum. So it will get the minimum value of 255, which will let it run smoothly. So like Hernan said, the Arduino in the middle right here, like I made a little stand for it. So I made a little stand, so it looks kind of nice. So the Arduino is the brain. It powers everything. It's being powered, but it's giving all the signals all over the Arduino. And all over everything, the proto shield, the dual motor, the wireless controller for the PSU controller. So having to do with all that, the main thing about this is that you have to program 2 different motors, which I call one A motor and B motor. So the main thing about this is that we have to be able to control each motor to go forward or backwards, or however we want it. So my main problem was that I didn't know on which side was which. So I messed up the wires. And I had a lot of conflict with that until I finally realized, I was like, so one thing that I've done to like actually keep everything in place is also that like for the battery pack, I made like these little like stacks right here. So I could just put them so I can keep them safely over here with the battery pack. So one problem that I had with another battery pack is that I messed up something in the connection and it killed my battery box. So that's why I'm using Juan's battery box to help me out, because mine's dead. So yeah. So I will demonstrate one side of the motor, because the other side is it disconnected, or when I was putting it back, it just malfunctioned. So. Okay, see, it would go forward, fully forward, and then when I go in the middle, it would go backwards. So it would go to the back, and then it would actually go. If I go slightly, it will go slightly fast. So, and I can go full fast. Same thing for the other side, but my problem was with the wiring, so I couldn't really get it to work. So, yeah. Yeah. Any questions? Yes, Michelle.
So what's your real life application? What would you use this for?
Like, right now they're using big type robots. Like an example would be like, some engineers have built some better technology to actually like help them out. Like also there's like robotic fairs, which can also like have competition between different people. Not just have fun. Yeah. Any other questions?
I'm a little confused. Why do you need two motors? Like, what's the difference between having one motor powering both sides versus two motors powering both sides?
So what you don't want is having the motor just going forward and backwards. Just like both motors go forward and both motors go backwards. You want each motor to have its own function. So like one can go backwards and go and just goes around like just spinning. So you want it to do that, so you can actually just control it. Instead of like if you want to turn, you wouldn't make the turn this way, you would go forward. Instead of having it just forward, backwards, you know, have its own function. Any other questions? Yes, Tyler?
What was your starter project?
Oh right, I'm sorry. So I'm sorry that my starter project kind of messed up, but what it actually did, like, it was my laser target kit. So what I would do, I would power it by a 9-volt battery, and it would power all these lights. So when I had this thread, they call it the trimmer. So when I would put it all the way over here, the lights would turn off. So when I had a laser and I pointed at the CDSL, which is a light sensor, all the lights would turn on. So it would allow it to have a little solar. It's kind of like a solar panel, but actually letting the lights turn on. Yeah.
What additions are you planning for your robot?
Oh, so what I'm trying to plan for my robot is trying to add some light sensors. So like an example, like Hernan said, like a robot would get out of control sometimes. So like adding a light sensor would allow it not to fall off the table. So adding all that is going to be pretty difficult, but you know, it's never hard just to try. Yes. And I'm also adding an infrared, which is for short distance. So if I can actually have it to go here to here, just as a distance, you know, just not to like, just for like little causes. Yeah. Any more questions?
Did you name your robot?
I had like the name. I had a name in plan. I was gonna call him Herbert or Edgar. Because like in the beginning, Juan would always mistake. He would always mistake some Hernan's name and call him Edgar. Like, but yeah. Any other questions? No? Okay. Well, thank you.
Hi, my name's Emmanuel, and I am a rising sophomore in Houston High School. So for my starter project, I did a mean-to boost backup charger, which could also be sort of like a power source that you could use. And it is also what I will be using today to power up my actual project. So it actually uses two AA batteries that equal out to 3 volts and generates 5 volts at the end. And then for my main project, I did a home security system with a temperature sensor. So I'm gonna go ahead and get that started. So pretty much how it works is it uses a photocell, which is down here, to get an analog read from any buzzer or close light. So I'm going to use a flashlight. So as long as I keep the flashlight connected onto it, it will not go off. But the moment that I take the flashlight off, the buzzer will start to go off. When I would input the code, it stops going off. And from there it starts to reset the actual system, and it gives you a 15-second delay to move away from the actual home security alarm system. And after 15 seconds, the laser has to be back pointing on it. If not, it'll start going off again. One of the challenges that I faced on it was the coding, because the guy that I followed, he pretty much built his own Arduino board, which is kind of ironic to do when you can just buy one. And the pinouts were completely different compared to the pinouts that I had, because he had an older version to it. And then I also had to use multiple different codes for the keypad, the photocell, an LCD screen which I am programming, and the buzzer. I had to combine all codes to make sure they didn't interfere with each other, causing one code not to respond because the other one was interrupting the signal. So that was a really huge part about it. The other part was actually getting it all to fit inside the actual box. Before today, this didn't really look this pretty. It looked like a jumble of wires. So, yeah. Any questions? What it actually does, it's like your home security system, like an alarm. And so what it does, it's like a little light or a laser. You can point at it right here. If you trip it, then it makes the buzzer start to go off. And until you don't put in the code, then it's going to keep on going off. Any other questions?
Is it a silent alarm or a alarm where someone can hear it?
Well, as long as you're inside the house, you'll be able to hear it. As far as outside, I don't think so. It doesn't use that much power to be able to generate such a loud noise. It's only like 5 volts. It's pretty loud inside the house, but outside, I don't think you could hear it unless you're like right on the wall.
Rising junior at Sharpstown High School, and for my main project I did a robotic arm, which is this. And the way it is, the structure, you can see is a IKEA lamp. We went and bought it at IKEA. So yeah, and that's the structure I used to make the arm. And I added, there's one servo on the bottom, one in the middle, and there's one right here, you can see it. It was over rotate. But I still have to install that one, and because I'm missing a potentiometer. But once I get that, I'll make sure I have it in there. And there's another servo right here which opens and closes the grip, and that's how it works. Well, the reason I have the potentiometers here are because they're the ones that are going to give me the movement to move the robotic arm. I had the challenges I had were all of them. It was pretty much like the whole project since I started. I always had challenges, and it was pretty difficult because I had no experience doing any engineering thing or anything like that. I had no experience at all, so everything was new and it was pretty hard. Yeah, because the staff always pushed us to do it by ourselves so we could learn more, like they said, and and this is how it works. Right now I'm using a power supply because the actual power supply that I was going to use is not working. It's not ready yet, but I'm using this power supply, so I have to turn it on. And once I turn it on, it give me the power I need for the circles. And you can see it moves up and down. It also has the gripper, it opens and closes. And this potentiometers give me the ability to control the arm completely in different parts. And I can use them to do many things. And as you can see, it's pretty cool. Any questions?
What was your starter project?
Oh, my starter project was a microbug, but I forgot to bring it. It was the same type as Dacia did. It's the same thing. And yeah, this is what I did. At first it was really difficult. I had no idea what to do with it. I didn't even know how to read the instructions, but I had to figure that out. Yeah, and the hardest part was to solder. This is how you solder, and it's like you put these sensors inside, and you have to solder across it on the other side. And yeah, we had no idea how to do it, but it was fun. I had a lot of fun doing it. Any other questions? Next turn.
What are you going to do with your arm next?
Oh, well, next, I have an extra circle, so I wanted to make it to rotate, so that would be pretty cool. So that's what I want to work on. Thanks.
What's her name?
Oh, that's not me. Any other questions? Do you
Okay. My name is Christian. I'm going to my name is Christian. I'm going into the 10th grade at Baylor High School. For my startup project, I did an EL wire, which is an electroluminescent wire. Really, like, I just made the connection from the power source to the wire, and when the current is passed through it, it glows, but you can't, I don't know if you can see it. That's how it is. Okay. And then for my more intensive project, I did my micro wind turbine. And so what it is it's a air core alternator, and it's just like it's a magnet spinning between copper wire coils, and the magnet like moves around the electrons in the coils and makes a current run through the coils. And I use it to power an LED. And what this is it produces an alternating current, and that makes a light bulb blink. Like it blinks whenever it spins. And I didn't really I wanted to be more constant lighting, so I tried to use what's called a full wave rectifier, which uses diodes. And the diodes keep the electrons running only one way, because the voltage on alternating current, it goes positive and negative. So this produces 3 volts, so it goes 3 volts positive and 3 volts negative. And when it meets at the 0 line, the light will go off. So I wanted to keep it positive, so it would just be bouncing. The line, instead of going under the line, it would just be bouncing on the line. And so I'll keep it positive. And then I also use a capacitor, which stores electricity while it was at the peak, so it would go down less. If that makes sense. So yeah, and for further, and so I just made the whole thing. This is Lexan. I had my instructor cut it, but I drilled all the holes. And then I did all this stuff, so yeah. And that was the hardest part, probably. So. Any questions? Yes.
Did you have to wind your own generator coils?
Did I have to do the copper coils? Yes, I did 320 wraps on it.
put it on the wind, would it work?
Yes, sir. Because that's like, instead of like, I use my finger, when I was testing it, I was using a drill, but it would spin with the wind, so
Hi, my name is Omar, and I'm a rising sophomore at Gibson High School. And so for my starter project, I did a voice changer kit. And the way that works is that I talk into it and converts it into a signal, which is then modified and then comes out through the speaker. So it works to some extent, but because of my brother who broke it a little bit. Hello. Hello. And so for my main project, it's one of the smaller projects you'll see tonight, but I reprogrammed this camera to take time-lapse photos, and so I actually had it taking time-lapse photos this whole time. And so after everyone's talking, I'll make it into a movie using Windows Movie Maker, and I'll get it on the projector for you all to see tonight, later tonight. And so one of the more difficult parts was difficult mainly because of its size, and so I'm gonna get all the code put into this little chip, which was really hard, and that's how I got myself burnt a few times. Something else that was difficult was the actual coding because it was the first time I did something like this, and it was really new to me. And so the camera worked a little bit. The problem I have with it was the shutter. It wouldn't work properly, but luckily I got it working tonight, so you can get a video. Any questions? When everyone's done talking and I edit it. Yes?
Where is it? Is it in the front?
It's right here, sitting on top of my laptop.
So where's the camera looking at?
The image sensor is right here.
So it's been taking our picture all this time, right?
Yes?
And what's the most interesting video that you've taken with it?
I haven't actually taken a video with it because the shutter didn't want to work with me.
How are you going to mount it in different places?
Oh, when I'm done with it, putting the chip onto the camera, I'll actually put it into this case. It has magnets on it so that I can attach it to a magnetic surface. So, for example, like this.
Yeah. I built this RGB LED light display, and what RGB stands for is green, red, and blue. So it's like this little light that you change to 3 colors and actually mix them. So, so as you can see on the bottom is where the 7 LEDs are with its resistors and transistors. And there are 3 transistors which go to each color of the pin, of the 3 pins. And right here in the box is where the Arduino is. So, and on the bottom, where the pink tape is covering, that's where all the wires are going from the pins of the LEDs to the Arduino, where it can get power from its 3.3 voltage, which powers everything. So, and then this is actually plexiglass. So, and then like what I did is you can actually take your own design, whatever you want, and you can actually make it onto there. And then what I actually did is I didn't want just one plexiglass, so I actually wanted to make more. So what I did is I made multiple ones, so you can actually switch them in and out. So yeah.
How do you control the color of the LEDs?
Control the color. Oh, so what you would do in the beginning is you would download this. You would download the code into the LEDs, and then you can actually modify it to pick the patterns of which colors you want to go after another. So that's how you do it. It has some code.
Working with 120 volts or 12 volts or 24 volts?
No, works with 2.3 volts. That's too much. At first I tried 5 volts, but the red kept flicking on and off, which is not good. So I had to lower it down, and that is why for each red pin of the LED, I had to use a 150 resistor to control the flow of it, not make it go over.
Okay. So we're going to stick around to allow you guys to speak to the students again. I'm sure there's some questions you have that are maybe not polite to ask in front of everybody here. So if you want to grill them, you're welcome to. And then we'll also have an opportunity to continue eating the food that we have. Ask more questions. I encourage you to go on the website. As I said earlier, we're trying to turn this into an experience that our students can use to go and get a college degree, an internship, or even their first job. So we put everything, all of their work on the website, and they'll be working these next few days to make all the formatting right and put all their documentation up so that you can see what they've done and their videos along the way. bluestampengineering.com.
That's wonderful.
One last thing, Robin and I have been working on this project for a few years, and it looks very different today than it did when we started. We're always looking to make it better for both the parents and the students. And the worst, well, not the worst thing you can say, but one of the worst things you can say is, we love it, keep it exactly the same. There's always room for improvement, and we'd love to hear your feedback. You can do this differently, you can do this better, faster, have more, anything. Please let me know, let Robin know, shoot us an email, tell me right now. I'd love to hear it. And have a great evening. Thank you.